In doing math, it helps to do the work yourself. So I'm going to encourage you to pause this video from time to time and do each step on your own, and then resume the video and compare your work to my own. This problem asks us to simplify this expression using only positive exponents. Now, there's several negative exponents. There's a negative exponent here, there's one here, there's one here. So we have a little bit of work to do in order to do this. The first thing I'm going to do is I'm going to go ahead and simplify this first one, rewrite this using only positive exponents. So this is y to the negative fourth, z to the fifth power. And the negative fourth means that we're going to rewrite this, and this right here becomes 1 over y to the fourth, or we can put this in the denominator. The denominator here, since there is no denominator, is understood to be 1, and so what we get is z to the fifth power over y to the fourth power. Notice that this answer has no negative exponents, so we've rewritten this with only positive exponents. The other expression here is this one right here, and there's a couple ways of doing this. One way is that we could go ahead and resolve this negative exponent here, rewrite this negative exponent using only positive exponents, and then take it to the negative third power. But I find it easier to go ahead and take each expression to the negative third power and then worry about the negative exponents. So what we have is 3x squared y over z to the negative first, all raised to the negative third power. And so each term in here gets raised to the negative third power. So that's 3 to the negative third power. If this is a negative number, you have to remember that the negative is also raised to the power. In this case, we don't have to worry about that because this is positive. X squared to the negative third power, y to the negative third power, all over z to the negative first, raised to the negative third power. Now, when we are multiplying a power raised to a power, we multiply the exponents. So what I get here is 3 to the negative third power. I'm not going to worry about what that is yet. X to the negative sixth power. 2 times negative 3 is negative 6. Y, this is a 1 right here. There's no power, so it's understood to be 1. 1 times negative 3 is negative 3. So that's y to the negative third power over negative 1 times negative 3. That's z to the positive third power. Now that I've done this, I'm going to, there's all sorts of negative exponents here, and I'm going to have to do something about those. Each of those negative exponents, it can be rewritten as 1 over that expression, so they all can be moved down here to the denominator. So that's going to be, in the denominator, 3 to the third power, x to the sixth power, y to the third power, z to the third power. There's nothing left in the numerator, so there's just 1. The last thing to do is go ahead and evaluate what is 3 to the third power. That is 1 over 27 x to the sixth power, y to the third power, z to the third power. So now what I have to do is I have to find the product of these two. So I'm going to take the product of this and this. I'm going to multiply these together and see how my terms can be multiplied. So I have z to the fifth power over y to the fourth power times 1 over 27 x to the sixth power, y to the third power, z to the third power. Now, what do I have in common? Well, I have a z to the fifth here and a z cubed here. So off to the side, z to the fifth over z cubed is going to be z to the second power. Since this exponent is positive, it's going to remain in the numerator. The z to the fifth power, there's more z's here, so it will stay in the numerator. So this is going to be like z to the second power and then a 1 in the numerator. With the y to the fourth here, y cubed here, well, those are both in the denominator. So we have 1 over y to the fourth, and we have 1 over y cubed. When we multiply, we add the exponents, and so that gives us 1 over y to the seventh power. My final result then is going to be in the numerator I have z to the second power, and in the denominator I have 27 x to the sixth. There's nothing to combine with the x's. My y to the third is now y to the seventh. And then my z cubed canceled out with my z squared up there in the numerator, so that is my answer. And notice everything has a positive exponent.